Okay, so this is week 2. We'll try to cover material that are on the Smith book from chapter 12 till chapter 17. They will go over 2 courses. Some of the stuff I'll cover here in combustion control circuit, but a lot of the stuff will be covered in HVAC electrical applications. So if you look here, we did cover control relays and overloads, thermostat, pressure switches, and electric control devices, basically thermostat. Some stuff you might not even need that much, but they touch base on it. For electronic control, there's so many controls here for each one of the equipment. So I'm going to go over the basic general ones. Heating control devices, that's mostly I'm going to cover with the NORA, and also for the gas combustion, and some troubleshooting for those controls. So the air conditioning controls are going to be covered in Bill's class, and also the HVAC electrical applications. Question? I'm just going over the. Good. So yeah, these are the chapters that we covered last semester, all the way to chapter 11, chapter 12 to 18. Will be kind of a joint venture between this course and those classes. And eventually, this week, we will go over the NORA book. This is really a good book to have. Keep that book. Also, it's available online for free from the NORA organization.
Or you can get the book for $15.
Yeah,
That's right.
which is very convenient.
On the
This is how it
website,
should be,
on
you know.
the NORA website.
15 bucks?
Yep. At the store, it's like 84 or something.
So again,
Yeah,
this book has been published by an oil company. So you're always going to see there's always a sales pitch when it comes to oil. Again, there's always some kind of interesting competition between oil and gas, but we cannot need both. So if you see here, they always talk about oil and how oil is the most dominant and the other kind of feeding. So leave away the commercial part and think of the information. And again, there is no one size fits all. It's always it depends on the situation. If you have a gas line, it will be kind of silly not to plug into it and use oil. What happened?
Hey, can we turn on the fan?
Huh?
It's a little too quiet for my taste. You know, some just white noise background.
Having technical difficulties here.
Really sure? It was chewing, I couldn't hear anything. So, Tuesday, alright? It's Tuesday, man. It's what?
You put book online
Yeah.
on the website?
Yeah.
NORA website?
Yep. So the only book you had to buy was the only one you had to buy, I think. Unless you sell your, unless you sold your books last time.
The only thing I gave them was
See, they made me get the last semester.
we don't use it at all, right? Yeah.
We use it for the lab. Hey, we use the residential oil burners for the lab, right?
Yeah, hold on. Let me,
Okay.
Okay, sorry about that. So again, this is week 2. We said we're gonna cover 2 books, so keep your Smith book, and we're gonna use the NORA book. So we will talk about basic electronic control fundamentals. That's Smith chapter 13. And we said for any kind of control, you need two things. If you want to control anything, what are you going to need? An input, right? You need an input and an output. Otherwise, you don't know what's happening. Like you need an input, make a decision, then you will do an output. You hit the gas in your car, that's the input. And the car's output is to increase the speed. You deal with the switching the gears, increasing the gas, increasing the oxygen, etc. So controls always need input and output. Then we'll talk about heating oil fundamentals, because I'm trying to prep you for your oil burner technician license. So by March, we'll fill the application that I will try to send that out, and hopefully you will get tested at the same time and get that covered. The Weinberger book is optional. I put it as in the syllabus for the lab. So if you can find it in a reasonable price, it's a really good, useful book. However, you can do without. I mean, it's there. If it's included in your book package, go for it. But it's really good, and it's designated and designed for oil burners in general. If you decide to go into oil, probably you want to have that book with you. Okay, so let's talk about what kind of controls do we need in HVAC. So what does human comfort consist of?
Humidity and temperature?
Humidity, temperature, and sometimes you can think about
Air
the
cleanliness.
draft. Huh?
Air cleanliness.
Light?
The air quality, noise,
Air movement.
air movement, draft. And so these things you want to control. That's why if you look at the remote control here for this AC,
Which he's gonna demonstrate by turning it on for the rest of class.
because it'll be noisy. Yeah, down. So we have control for the fan, and if you look at the fan, there's a mode where it's very quiet so you don't hear it, because people get distracted by the fan noise. It can be too loud, and some people actually like it. Some people buy white noise machine that sounds like a fan. So it depends. It's always a personal preference. Some people care about draft, some people don't. Some people like it colder, some people like it warmer, and so on. So you have controls for the fan, for the temperature, and for the noise. So we need to control the temperature, and again, as we said before, when you need to do control, you need input. So what is going to provide you with the input? Sensor. What's a temperature sensor? We have many ways to sense temperature. Give me an example.
The thermocouple.
Thermocouple, thank you. So this thermostat has a thermocouple, which is two wires made of different metals that makes, excellent. They are spot welded. When combined and exposed to temperature, they generate a small amount of voltage. That voltage we can measure and translate into temperature. The other kind of temperature sensors is bimetal. Bimetal has been around for a long time because somebody realized at some point that metals do expand with heat, so they have manufactured very small bimetal spring that will expand and contract with heat. And if you notice here, it's very long, so we can have more expansion at certain degrees. It's not as sensitive as thermocouple, but it did the job for a long, long time. So either by expansion and contraction of metals using thermocouples, what else? Expansion and contraction of liquids, that is also possible. So we use this as our input, then we translate that into a signal to do control. So that's temperature. What about air and water flow? How do we control that?
Pressure,
Pressure? What else?
mechanical movement.
Valves and stuff.
Valves?
Water pump.
Huh?
Water pump.
Water pumps? They can do control the flow. And also we can use
the expansion tanks, the water.
expansion tanks, which also does that to pressure. And also we can have some kind of a mill-like vanes that will move, and each turns will give you an indication of how much volume is going. So you see that a lot with water flow. What is the difference between water flow, flow and airflow?
Water is heavier.
Heavier. Okay. What else?
I think got pushed against gravity.
Ah, that's really good. Denser, what does that mean?
Just got
Air is compressible.
Yeah, okay. Water is not.
water's not.
Water is not compressible. So water is more reliable when it comes to volume. You get the temperature, you can find the volume of the water with some kind of certainty. With gas, it's really difficult because gas you can compress. So it's getting a little bit tricky. We're trying to control the flow of air and the flow of water. So air in air conditioning usually is measured in what unit? Airflow.
The CFM.
Huh?
The CFM.
CFM, cubic feet per minute. Timing. Timing is very important. We put timers on all those controls. Why? We want a lot of delay. We want delay. We want to time things before we go. For example, in a lot of gas furnaces and a lot of boilers, they have something called pre-purge. What does that mean? I want to turn on the inducer fan and kick all the existing gases inside the chamber outside.
So you don't get a big combustion chamber.
Yeah, you want
chamber
clean
basically.
slate. You want to start with
Yeah.
completely clean slate. So you will empty everything out. For that purpose, you're gonna have a timer because you will have delay before you start your ignition. So first, you will turn on your timer, and after a certain amount of seconds or minutes, you will stop and or continue turning the ignition. So timers are done sometimes the old-fashioned way. If you look here, this is an old timer which has a reset button, and it's set on spring-loaded mechanism. So the spring will be loaded at certain temperature or certain time, it will pop back. So in the old days, timers were done with springs. Now timers are done by transistors. So if you're one of those hobbyists who go and buy those little ACs to make your own circuits, probably can go to Radio Shack in the existing world, or Amazon, and you buy a small transistor, small IC, that's a timer, that will delay. You will energize one end of that timer and it will not get power until like whatever time is written on it. So 15 seconds, 20 seconds, and so on. There's also thermistors. Thermistors, what do? They do also measure temperature, but
It's applied differently, right?
Huh?
It's applied differently than like a thermocouple. Right?
it's different. It's different
it's
because thermocouples produce voltage when they get heated. Thermistors, they change resistance when they get heated. So let's just write this down. For temperature, we have thermocouple. Yeah, by middle. And to illustrate, looks like a small wire and another wire joined them together. That is a thermocouple. And luckily I have one with me. You can't really see it. Different color. So this is a thermocouple. As you can see, this is plugged into your multimeter. And if you look here, there are two wires joined together. And as you touch this, it will change temperature. Actually, let me pass this through so you can play with it.
So even if you touch with that and the pipe, it's gonna show you right
Yeah.
temperature?
Yeah.
You sure?
If you touch it with what? If you even touch with your finger.
It's not too accurate though, because look at
It depends on the. It has a function of time. It's
No.
not very quick, but if you wait long enough, it will give you the temperature within plus or minus 1 degree. They have ones. The thinner they are, the more accurate they are, but different range. So you can look into it. And I also want you to see if you want to measure the voltage, put it on DC and heat it. If it's high enough, you'll see some small little voltage. So generate voltage. I'll pass it to you. You can play with it. we did talk about those a little bit. And we said also, when they're heated, so get bigger. And we said we have also thermistors.
Nice and cool.
Did you put underground? For right temperature?
I was thinking about it.
So they change resistance based on temperature. For pressure, I hope you're getting ideas for your paper, because eventually you have to.
Yeah, when do we
write
have to
about one of
submit
those
our
things.
ideas?
Huh?
When do we have to submit our ideas?
I don't know. Anytime. Get an idea. I'll post something online. I actually put a
Yeah, so then mine on the discussion board already.
discussion board. I put a link there, so you can look at the discussion board so you don't replicate whatever somebody else is doing. For pressure, how would we measure pressure?
Oh,
Gauges,
There are pressure gauges, but
PSIs.
PSIs, that's the unit. And so far there are two common ways, and I'm sure there are more. I hope you tell me what you find out for new pressure sensors. Let's turn that one. Whoops. So either you will use a diaphragm, there's a G in there, right?
sure. Somewhere. I think that's right, actually.
Yeah. So you have an opening, and you have a flexible membrane here that will go up and down, and it will push on a needle.
Isn't that
That's
similar
it.
to an expansion tank? How it's got that belly that expands?
Yeah.
When the pressure changes?
But this is very small membrane, like
Yeah.
about half an inch. And there's a needle in it in the middle, it expands back and forth.
Okay.
So that's one way to measure the pressure, by measuring the change in distance between here and here. See displacement. So this little diaphragm will go up and down, and based on that you can measure the pressure. It's not, of course, there are many people who try to make better and more accurate measurement, and it does the job, depending on how much surface area you have and how much flexible the metal is. And if you have guessed over time, this will need to be calibrated, right? Because the metal will fatigue, it will change. When you get a piece of metal and change it back and forth many times,
Yeah.
eventually it will not lose, it will become more flexible, right? And eventually metal, if you push it back and forth, it will break. The second way, and I hope somebody picked that for the paper, is called a strain gauge.
Oh. Strain gauge. I remember.
Probably you know strain gauges. So strain gauges,
Yeah, they're big on bridges and stuff.
and everything now.
Yeah.
So strain gauges, small, tiny, very tough to see pieces of metal. So it looks like a grit. What happens is, when this grit changes shape based on the pressure, those little tiny, I'll magnify that, it will get smaller. One of them will get very small because you are expanding, right? If you get a piece of rubber and you pull on it, it will change shape, right? When it changes shape, what will happen to the resistance? It will change. Yeah, yeah. Because we say the wire, small wire, has more resistance than a big wire. Does it make sense?
Yeah.
Okay. So as it changes,
You forgot the end. Inching.
I eat some more sometimes. Inch. Okay? So we learn about strain gauges now. This is for pressure. We will talk about all these things in details and we'll play with them. But your job is not to fix them or design them. Your job is to know whether they work or not, or they're doing their function or not. So let's keep it simple, but it's good to have an idea how do they work. If you know how it doesn't work, you can know if it's working or not. We'll talk about flame level. So for those who did the lab yesterday, and when we had the CAD eye cell underneath, and we exposed that to the light, did you notice that if you have the control with the screen, that will show a number of the ohms? Until your flame is proven, then you see the number of the ohms changing as we increase and decrease the light. You saw that, right?
I didn't have that screen, but.
Okay, so what happens is, this is kind of detecting flame and also telling you how much flame is there. So there's many ways to measure flame, and also it's a big deal when it comes to industrial boilers because you want to measure how much flame is there. You don't want to see if there's flame or no flame, because we have, it could be small candle, it could be like huge flame. So flame detection system gets really involved when it comes to commercial. For residential, it's not that involved. You just want to know if there's flame or not. The fire is not that big. So for flame level or detection, there's big variety of sensors. So can somebody tell me what are the components of flame when you have a fire?
Carbon.
Not the product. You have a fire. What's happening in a fire? Hot air, heat. So you can detect heat, right? What else?
Chemical reaction.
Light.
Chemical reaction.
Light. Detect
Light. What kind of light? Depends. Some lights are orange, some flames are white, some flames are kind of bluish. So you can detect the light and color. What else?
Temperature, obviously.
Temperature. What else? Huh?
Radiation.
Kind of with the light comes radiation, which also
Heat buildup.
heat buildup.
Smoke flow.
Smoke, but you should not have smoke.
No, it's like hot air.
Yeah, that's
Combustion.
yeah.
Like, yes.
So it's in heat, air, color, and based on also radiation, ionization. So ionization is when the gases get too hot, they become ionized and have charges. So we can detect ionization also in the air. We will use whatever we can to measure how much flame we have in the fire. For residential, for the next 10 weeks, we'll talk about only the CAD eye cell, which is very simple. It looks like the night light. We turn off the light, it turns on based on resistance. But after spring break, we'll talk about the other types of flame detection systems. Light sensors, kind of like flame but different. The only sense is light. And motion sensors, we have one here in the class. How do they work? Hopefully somebody will pick one of those sensors as well. Okay. So if you skim through chapter 13, you'll find some information about sensors and details about components about oil burners. Liquid level. How do we measure liquid level? There are at least every power plant.
No,
The exam?
Yeah, the class.
Oh, with
low water
a
cutoff.
sight glass.
Yeah, low water cutoff.
Yeah.
How do you measure water level in a tank? There are so many devices. Some of them
A float.
float.
Yeah.
That's the most basic one that you have in your toilet.
Like a laser.
Or your
There's a
oil
laser,
change.
there's light, optical.
There's another one that it's like that heater. It's like a little tank like that.
Yeah.
And it tells you that if it's almost done, you should refill it.
I'm sure there's a float in there. There's another way that you have, yep,
There's the one where there's a signal electricity through the water.
yeah.
Yeah.
Electricity levels, so whenever it hits, it will go down and up. So there are many ways to measure water level,
Like-
liquid level inside
Like
your.
electrode.
There's electrode, yeah, it's kind of like electrodes, but measure the water and if it connects, there's water, if it does not connect, there's no water. So there's many ways to measure liquid level. Liquid temperature, you're gonna use thermocouples mostly, sheath thermocouples in plastic because they won't rust. Regular thermometer will work, so that's one way to measure liquid temperature. Steam pressure, that is very, very important.
Probably the same device that you talked about there, right?
Yeah, you can use diaphragms, you can use, again, if you took power plant, pressure sensor probably was at least half a chapter with the siphon and the loop and how much pressure you put in the pin. So you wanna measure the pressure, whether high or low, especially if you're running with steam for heating in a house. What is the maximum steam pressure in a house?
15 or 14.9.
No.
Great.
Not
Huh?
Great.
2, close enough.
steam pressure or
Yeah, in a
gas
house.
pressure?
Steam pressure in a house should not exceed 2 psi.
I thought it was.
But low pressure boilers are rated at 15,
Oh.
but that's for industrial. For residential, if you're in a house, the steam pressure should not be more than 2. Air pressure, air temperature, same thing. Where's me that? Air movement, where is that important?
In a building.
Huh?
In a building.
Where?
If you're like
In our equipment.
Oh.
The
if you're like a building with multiple
pressure.
Occupants?
Does anybody have a gas furnace? Or a gas boiler?
Oh, you don't want a lot of draft in your chimney.
Yeah, so there is a, once you turn on the furnace, there's a sensor that will validate that there's airflow. There must be airflow before we turn on the gas.
And in the right direction too.
Yeah.
Because there's a back.
It opens the gate.
Sensor.
Validate that there is airflow. Why is that? Especially with gas, not with oil.
You don't want standing gas.
Yeah, you don't want standing gas, and you're pumping gas, so you are increasing pressure. So that could be a problem. Yeah. It's not even about that. It's not about safety, because gas will easily light, and again, gases and liquid are different. Gas will build pressure. What does build up pressure do? Explosion. So, as long as you don't build pressure, that's why we have relief valves everywhere. Relief valve, pressure sensors everywhere we go. Pressure sensor and relief valve, so we do not have that problem. Oil burner flame. That's something we're going to detect using CAT's LI. Okay, I want to take 10 minutes, and I want